Hello, everyone, and thank you for joining us today. My name is Kristen Vandewaal, and I'm the Regional VP of Sales for the Midwest and West. I'll be your host for today's webinar titled Introduction to Aerial Cable Systems, Benefits, and Applications. Aerial spacer cable systems offer many advantages over traditional bare wire, including increased reliability and design flexibility. This webinar will cover the fundamentals of spacer cable systems, discuss its many benefits, and review specific applications for which this system is an ideal solution. For today's format, we'll begin with a 60-minute PowerPoint presentation, and we'll follow that with a 30-minute Q&A session for a total of 90 minutes. During the presentation, please use the Q&A tab to submit your questions. Anyone who submits a question that we don't get a chance to get to will receive a response in writing from us. Also, there will be a brief 3-question survey that pops up in your browser when you exit the webinar, and we'd greatly appreciate your response. Now, I'd like to introduce you to today's presenter, Ted Gardner. Ted has worked in the electric utility industry for over 30 years. He graduated from Western Michigan University in 1997 with a degree in electrical engineering. He started his career as a distribution engineer for American Electric Power and has worked primarily in utility equipment manufacturing for the past 24 years in both sales and marketing. He's been with Marmon Utility for over 15 years, working as a direct sales engineer, regional sales manager, and currently as application engineer and project manager for Overhead Solutions. He's from Portage, Michigan, where he lives with his wife and 2 sons. Now I'd like to turn things over to you, Ted.
Thank you, Kristen. I appreciate everybody taking time out of their schedule to join us today. We'll jump right into to our content here. There we go. Yeah, this is primarily showing that Hendrix aerial spacer cable systems is not necessarily a new product. We've been in the industry. We've had installations since the early to mid 1950s. In fact, the location where our facility is in Milford, New Hampshire, there's still some of the original spacer cable that's still in the air, some of the original covered conductor that we had. So it's not a new product. It may be new to a lot of our listeners today, but we do have installations in all 50 states. We're up over 75 countries now and on all 7 continents. Like I said, our facility is located in Milford, New Hampshire. This is one of my favorite pictures that we've got from 1954, the public service of New Hampshire installing spacer cable, not far from our facility. And like I said, a lot of that conductor is still in service today. Everyone knows, when you look at your standard bare wire electrical systems, you've got bare conductor, usually on cross arms or some type of standoff bracket. And between the phases and the neutral, the primary means of insulation is open air. And as we all know, that's kind of an inherently, unreliable system. It's prone to faults caused by, vegetation, wildlife, things like that. And it requires a lot of separation. You're going to need a lot of air between the phases to provide that insulation. If we look at the NESC code 230D, it says that covered conductors shall be considered primarily bare conductors for mostly clearance requirements, except that the spacing between those conductors can be reduced. So essentially, the original concept of aerial spacer cable was we're going to replace a good percentage of that air used as insulation with a polyethylene, a covering on the conductor. So we can shrink the overall footprint of a spacer cable system quite significantly. And we'll talk about some of the specific dimensions here in a minute. We want it to withstand short-term phase-to-phase contact with vegetation, but it's got to be, it's primarily, momentary contact, incidental contact. Primarily what we want to do is limit the charging current on the surface of the conductor. So this isn't what you would consider insulated cable. Although The covering does have insulative properties. Obviously, you have nearly line voltage on the surface of cable, but what that covering really does is it limits the charging current on the surface. And our goal is always to get down to about a third of a milliamp on the surface of the cable. That allows us to move it a lot closer together, and it minimizes any faults that can occur from momentary contact. Uh, Control of the surface charging current is really the key. The other thing is maintaining the covering integrity over its useful life. I think most of us in the industry kind of look at, electrical equipment has got like a 30 year or so useful life. Um, I think we've said 30 to 40 years, but like I said, we've got some aerial cable that's been up in the air, going on, 50, 60, close to 70 years. So this is your standard aerial spacer cable, tangent construction. A couple things to point out. It's a messenger supported system. So the phase conductors just kind of sit slack in all of these spacers, these diamond shaped plastic spacers, which are made from the same polyethylene that we put on the covering of the conductor. You'll notice that they're kind of sitting slack in those spacers, and you're going to have one of those spacers about every 30 feet. The other thing you'll notice is we only use one side of the pole, so it's a pretty compact construction configuration, and we're only using one side of the pole. So you can literally take another one of these tangent brackets and put it on the back side of that pole, and you've doubled the capacity of your pole without having to go with a taller one. So it's a really efficient system from a space constraint perspective, but with that messenger supporting it, it's also a very strong, a very reliable system, especially from vegetation, trees and tree limbs falling on it. The messenger really protects those phase conductors from anything coming in contact with it. And the low leakage distant current on the surface of the cable minimizes or virtually eliminates any faults, whether it's a momentary or a sustained fault. We always kind of start with the conductor itself. For spacer cables, primarily all aluminum conductor, compact conductor, and where that comes into play is when you splice it. Obviously, you need to know it's 336 compact conductor. So you want to make sure that your connectors and your splices used for that are appropriately sized. And then we primarily make 3-layer cable these days. If you looked in our catalog, 10, 15 years ago, you'd see spacer cable, and then you'd see part numbers for tree-proof spacer cable. And that's the difference between 2-layer and 3-layer. And the third layer was always this strand shield, this initial thin polyethylene covering that goes goes over the strands of the conductor, and that just reduces the voltage stress, kind of balances it out throughout the peaks and the valleys of the stranded conductor. And then our standard product has got a layer of low density polyethylene, and then the outer jacket is what we call our high density polyethylene. And like I said, that's the same polyethylene material that we make all of our insulators out of and all of our spacers. So we know that all those materials are going to behave the same from an electrical perspective. That's one of the things that I'll refer to it a lot as is a spacer cable system. And we look at spacer cable as an engineered system. All these component parts work together from a mechanical and electrical perspective. And we've always maintained we want to manufacture the full system. That way we know that everything is going to work and we get the most reliability out of it. The interconductor, we'll talk a little bit about spacer cable versus tree wire here in a minute. But the core conductor can be all aluminum conductor, ACSR, or even triple AC, aluminum alloy. And then the outer jacket, like I said, is high density polyethylene, comes in black and gray. Our system voltages start at 15, go all the way up to 138 kV. It gives you the reduced spacing, a lower partial discharge, higher BIL rating. You'll get about 200 kV just by the covering that's on the conductor itself, and that's our our thinnest conductor at 15 kV. One thing you'll notice is it's not, I'll refer to it a lot as covering. Um, it does have insulative properties, but personally, I don't like to refer to it as insulation, especially when we start talking with linemen. If you start talking removing the insulation, the thickness of the insulation, I don't want to give them the impression that this is fully insulated cable. This is not. This is considered a dielectric covering. So it's not insulated, it's not shielded. So from an operational perspective, it's still treated just the same way as bare. Now there's some advantages, some benefits about moving it close together, but there's still a minimum clearance that we need to maintain between phases. Incidental contact, momentary contact, it'll be fine. You still won't cause a fault. How long can a tree sit on it before it faults? It really kind of depends. We've heard stories of trees sitting in it for 6 months, up to over a year before we even see a fault on it. So it's pretty rigid stuff, high BIL, high impulse strength, and UV resistant. We'll hear a lot of clients will call it all Hendrix wire. Some will call anything covered overhead as tree wire. We differentiate between spacer cable and tree wire. And a lot of that, the main difference for those is it comes down to the core conductor. Tree wire is mainly bare wire construction, like you see here, pins, insulators, cross arms. You're going from pole to pole without any other type of support. So we need a stronger core conductor. That's why tree wire is typically covered ACSR or covered all aluminum alloys or triple AC. Now, when you get into some of the bigger sizes like 336 and higher, you can use AAC as tree wire because you've got such a good amount of aluminum. It's still relatively strong, but your typical tree wire types are ACSR or triple AC. And spacer cable is going to be, your all aluminum conductor. The covering, we've historically made all high density polyethylene, but we've also here in the last couple of years we've started to see more customers asking about cross-link polyethylene. So we have that available as well. But whether it's black or gray, the UV protection is significant. Really, it's just a personal preference as to the color of the conductor now. From a UV protection perspective, the technology, the additives that we had to add to our gray to make it UV resistant is nearly as UV resistant as the black, always has been. Some of the mechanical characteristics of tree wire, since you are dealing with a lot more tension, you cannot terminate it. You can't dead end it over top of the covering. So the covering has to be removed for dead ends. But other than that, the core conductor itself, the covering, the number of layers, the materials that we use, the thicknesses, all of that are virtually identical between tree wire and spacer cable. We really only go up to 35 kV. We have done a couple of 69 kV projects with tree wire. So yeah, all that's available. The messenger, when we look at messenger is really kind of the backbone of the spacer cable system. Like I said, it's a fully messenger supported system. I like to tell engineers, spacer cable is kind of like a one wire system. When you look at it, you load all the mechanical characteristics of the messenger. When you're looking at sag and tension, the primary means for that is going to be the messenger. The phase conductors and the spacers themselves are really distributed weight on that messenger. Most of our standard messengers are what we call AlumaWeld aluminum or AWA messenger. And that'll typically have 5 strands of AlumaWeld that gives us a lot of strength. That layer of aluminum on the outside of the steel helps us with some conductivity. but it also protects it from the elements. Covered conductor gets used a lot in, corrosive environments, seacoast applications, and that helps protect the steel. And then we've got 2 layers of pure aluminum to help us with the ampacity, because typically your messenger is going to be used as your system neutral most of the time. If we can get enough ampacity out of that, a lot of clients will use that as their system neutral. So if you look at our ampacities, we can get up over 400 amps with that. This stops at 60,000 amps or 60,000 pounds of rated breaking strength, but I actually think we've got some larger messengers that we use with some of our larger cable sizes these days. But like I said, it's going to serve multiple purposes. It's going to protect the system from any falling branches and tree limbs. It's going to work as your system neutral. Most clients will ground it at every pole. Our recommendation is to ground it at least, at the most, every 500 feet, but a lot of clients will ground it at every pole. So it kind of even works as a shield wire because it's up above the system. The spacers themselves, like I said, these are what's going to connect and isolate the phase conductors from that system neutral. And the key part of this is the material that we make it out of. One of the reasons we've maintained control and manufacturing over all these parts is so we understand that this material that these spacers are made out of is identical to the material that we put on the covering of the conductor. So we know from an electrical perspective that those are going to behave and be compatible between the two. Our standard RTL spacers, we start at a RTL 15, which is good all the way up to a 15 kV system. Your phase-to-phase spacing on those is going to be 8.5 to 9 inches. So pretty tight configuration. Our next size up goes from 25 all the way up to 46 kV, and our phase-to-phase spacing there is still only about a foot. So all the way up to 46 kV, you've got a window of only about 12 inches from phase to phase. So it's pretty tight. And then the top to bottom dimensions are shown there as well. So I'll show you a couple pictures of how we can stack them vertically as well. And we've also had clients that use a high strength cross arm and kind of stack them horizontally off of those cross arms just to get more conductor in a smaller space on the poles. They're all made out of our same gray track resistant, UV resistant, high density polyethylene. You can install and remove them with a hot stick. I've never done it before, but I understand it can be done. It's not the easiest thing in the world. We also have a Geo 95 version, which is a standard that's used primarily out west, and that's just another size up. So the face-to-face spacing on those is going to be about 18 inches, and then we make one size for our single phase spacer, which is our RTL 20. That's going to be good for 20 kV from phase to ground, which is good all the way up to a 35 kV system. So a lot of these tables and these dimensions and stuff that you see here are taken right out of our catalog literature and our cut sheets. All of these spacers are also available in a DM version, we call, and instead of the plastic clamp that clamps to the messenger at the top, it's actually a stainless steel bolt that'll hold it a lot tighter. It's a little more time consuming to install, but if you get into any high wind areas or if there's any significant elevation changes, we want to make sure that these stay properly spaced between each other. These are going to be spaced about every 30 feet, but that's not a hard, fast rule. The key is between in any phase, we want them equally spaced, and 30 feet is a good number. I think in our literature, it might say 25 to 35 feet, but more than anything, we want them equally spaced because they're really supporting the weight of all the conductor in a span. Our 69 kV spacer, you can see if you're familiar with these, our part number has got a little bit of a extension on it. These only come in a DM version. We switched to that, I want to say 4 or 5 years ago, and then we've recently converted that so that it can be installed with a hot stick. So that's what the HS on the end of that stands for. So it's hot stick installable. We've changed the design a little bit more. These were getting pretty flexible because they were still all plastic, and obviously, the more you stretch out plastic, the more flex you get in it. So that cross member is actually got a high strength fiberglass rod in it, similar to what you'd see like in our line post insulators. And that minimizes that flex. It's a lot more of a rigid design than some of the first designs that we had. And then our newest spacer is going to be on the right. So obviously, we kind of maxed out the overall size at our 69 kV spacer. And when we came out with 115, 4 or 5 years ago, we had to really kind of start from scratch and really come up with a more rigid, a wider design. And that ability to take a fiberglass rod and overmold our polyethylene over top of it, the technology that we use with our insulators, our line post insulators, really allowed us to design these basically a suspension insulator that's still going to support the cable. And then there's a high strength cast metal kind of umbrella arc on the top. So we still maintain that triangular shape, which kind of helps with the losses between phases, um, and the angle between the phases and the system neutral. But this allows us to get still quite a bit of current or of conductor in a pretty tight space. So you can see that spacer is good up to 138 kV, and it's still only 6 feet between the two bottom phases, the two outside phases. So it's still pretty compact. And then our high density polyethylene insulators. And this really applies to, any cover conductor, whether we're talking tree wire or spacer cable. We recommend a polyethylene insulator. This slide kind of shows all of our different arresters or all of our different insulators, including our trunnion, our clamp top insulators, but the tie tops, any of the tie tops that you see, the vise tops, which is the one kind of right in the middle, is what you'll find. That's kind of our standard insulator that we use with aerial spacer cable, so it eliminates the need for any ties or covered tie wire or anything like that. And then we've got our line post product line kind of across the back there. All molded in the United States, 100% high density polyethylene. And it's all got they all have a lifetime warranty on them as well. One of the questions that came up, especially early on, when we started making spacer cable, or even covered conductor, was the use of porcelain insulators. And this is the main reason we developed our own tie top insulators in the early to mid 60s, was we were starting to see failures in the covering, primarily at higher voltages, 25 and 35 kV. So that kind of pushed us towards developing our own tie top insulator. And then about 10, 15 years later, the late 70s, early 80s, I think it was, we developed our vise top insulator. And that just kind of took things a step further. Still all made out of the same high density polyethylene, but like I said, it eliminates the need for any ties. So that's kind of our standard offering. But one of the things we recommend is, like I said, covered conductor, whether it's tree wire or spacer cable, using a polymer insulator. The best thing we recommend is a high density polyethylene insulator, like we manufacture. And what's also, we also make a flame retardant version of our tie top insulator that will melt, but it won't ignite. So it's a proprietary material that we use, and we also have a high temp insulator. We've got a handful of customers that like to run their systems a little bit hotter than normal. So we've got another blend that actually has a higher melting temperature. It's not considered flame retardant, it's considered high temp. So we've got two different versions of that. So those will let you run about a 200 degrees C operating temperature on your conductor before any damage occurs. The brackets on our hardware, and these are just a few snapshots out of our AC drawings, our standard construction drawings. On the left, you can see one of our light running angles, we call them a light angle. So our standard tangent construction will go from 0 to 6 degrees without having, without any issue. From 7 degrees all the way up to 60 degrees, you just turn the corner on some pins and insulators, preferably our vice top insulator, and then you can use a running corner on the messenger. If I flip over to the right, that's what we call our heavy angle, or our stronger angle. That's good from 60 all the way up to 90 degrees that we can turn. And all we do is really just double up on the pins and insulators. We add, it's kind of hard to see in this picture, but we add a little bracket to a little plate to the bracket that allows you to put double sets of pins and insulators. And it just kind of increases that radius on that covered conductor a little bit. But the main thing you'll notice is we're double dead ending the messenger. So anything over 60 degrees, we want to double dead end the messenger. And we don't show it. You can kind of see the bracket where the messenger or the guy wire connects. We're really only worried about guying the messenger because, like I said, that's where all the load is being carried. That's all we're typically worried about guying. The one in the middle, a pretty common question that we get is, what does a transition pole between covered and bare look like? And that's what we show here. So you can see it's just basically a double dead end on a set of most likely 10-foot cross arms. We use grips for our dead ends that allow them to be installed over top of the covered conductors. So what you'll see is we go through the grip up and over the pole with a set of pins and insulators to help kind of train and manage the conductor. And then the covered conductor, you strip a couple inches off the end, and then you'll connect it to your bare ACSR, just like you would, any other bare conductor. So you've got covered conductor over top of the pole. Really helps you out with wildlife outages getting in there. And one of our rules of thumb is anytime we remove the covering, whether it's for a tap or a transition pole or anything like that, we recommend installing lightning arresters. The other thing that you'll notice on here is these bubbles that show the numbers on them. And I kind of cut them off on these drawings, but if you look at our drawings, and they're all available. Most of them are available on our website. You'll see they've got in the lower left-hand corner a bill of material. And they're color coded. So you see some of them are black and some of them are red. The ones that are listed in red will be all of the pole hardware that we don't supply. All of the part numbers that are in black are what we do supply. So if you're looking at putting together a bill of material for a project, we can obviously help you put that together, but we can come up with a list of parts that you would need, both Hendrix supplied and non-Hendrix supplied. So I always try to point that out, especially when we're working with distributors, because obviously they have access to a lot of that the material that we don't. Some of the other configurations, the one on the right here, we've got 6 circuits, and you can kind of see how we can stack those circuits vertically, and then we're utilizing both sides of the pole. From an engineering perspective, one thing to point out is obviously we're dealing with a lot more weight, both from a conductor perspective, but also you're dealing with a lot more surface area. So spacer cable in general will pick up more ice and wind loading. We compensate for that. We design for that. And we can help you guys out with that. And I'll talk about that here in a minute. But again, we place all of that load, wind, weight, surface area, all of that on the messenger. So, that's what we're focused on. And we can even, we've got designs, we've got standard construction drawings for stacking 4 circuits, and you can take that same angle, double up on those pins and insulators, and turn up to a 90-degree angle. So with the lack of tension on those phase conductors, there's quite a bit of flexibility that we can have. We can roll those phases vertically and dead end them. We can spread them out on a cross arm like this. The second picture from the left, we show a 3-phase transformer tap, but it's still in that triangular configuration, our standard tangent configuration. What you'll see is those taps, and I only show a couple of them. It's kind of hard to see the third one, but those are spread out 24 inches from the bracket or the spacer to the first tap is 24 inches to the next tap is going to be another 24 inches, and then the tap on the other side. So we're maintaining that bare wire clearance, but it's still in this tighter configuration. The other kind of rule that we follow is we always want three of the four wires covered. So anytime we've got a tap that's open, like we show here, we've got a material called line duct that we snap over top of the messenger. And that's really a wildlife guard. So if any critters or birds or anything get up in there and they're standing on those taps, they're not going to brush up against the grounded neutral or the messenger and get zapped. But you could take that same, the messenger where that's attached and leave that alone. Take that spacer out and hang a crossarm. Spread those phases out horizontally on a crossarm with just a set of pins and insulators, and then you could just open up the covering and make your taps right in a row for your three-phase bank or your three-phase switch or whatever you've got, just like you normally would. So again, quite a bit of flexibility when it comes to the arrangement of the phase conductors. The last system component that I cover is our support services. And this is really key, especially if you're new to spacer cable. We offer a full range of engineering and what we call our field service. Engineering, we can do anything from, we've got clients that'll send us just a list of parts and we quote that and send it to them. Some of them will send us a list of AC drawings and say, I want 25 of these and 2 of these and 4 of these, and then we build up a bill of material off of that. We've got some engineering firms and some other more experienced designers that'll design a full spacer cable system. Then they send it to us and we just simply do a design review. And then we've got all the way to clients that say, I'm going from, this corner to this corner. It's about 1.5 miles. Give me a bill of material and we can literally do a full design from end to end. So we've got a lot of capabilities there to make sure it's designed properly. We don't charge for most of these services. It's included with the material. So I encourage anybody, especially if you're new to spacer cable, to definitely take advantage of the engineering service. The other thing is our field service. So we've got a field service group, and these guys literally travel all over the world helping linemen put in spacer cable. They'll do classroom training. They'll do outdoor training yard training. They'll be on site during the initial installation process. And one of the most important things that we do is after a project is finished, they'll come back out and do a full circuit inspection. Everything is photographed and documented, any deficiencies that we find, and then every customer is provided with a full written report. In addition to the installation services, we also do a lot of operating and maintenance service. So this has become really kind of a key component, a key service that we offer to a lot of customers because they may have some older spacer cable on their system that is maybe, installed, and maybe their current batch of line workers don't really know that much about it. Maybe some of the older guys there said, I remember putting that stuff in, but we really haven't had to mess with it, in the last 20 years. And that's pretty common. To a certain extent, that kind of works against us a little bit. Familiarity is something that is good for us. But if you don't have to maintain it, you don't have to service it very often, you lose a bit of that familiarity. So I would encourage anybody that has some of the existing spacer cable system and they have a lot of questions, set up some training for us to come out. And those guys will kind of come in and do our O&M training. And we make the assumption that you've already got spacer cable on your system, and you just need to know how to splice it, how to ground it. If you've got a tree laying on the line, what's the safest way to remove it? You get a broken bracket or a broken phase conductor, how to fix it, broken pole, the best way to kind of attack that. The other thing I'll tell a lot of clients is even if you don't have spacer cable on your system, so many line departments are running so lean these days with mutual aid. You may be traveling to other utilities, especially out east. Spacer cable and covered conductor in general is really prevalent out there. So they're going to run into it eventually, and a little bit of education goes a long way, especially when you're dealing with something different and unique like spacer cable. So um, most of the time, a lot of the questions are relatively easy to answer, but it comes down to the right tools and the right training. So get in touch with your sales guy. Um, or one of our regional sales managers, and we can put you in touch with somebody to come out and do some training. It's probably a good spot for me to get a drink and see if there's any questions on kind of the overview part, um, or do we want to wait till the end?
You have one question, Ted, that I can ask you now. So one attendee is asking if you can go into more detail on ice accumulation on covered cable. You mentioned that it picks up more snow and ice than bare, and he understands the diameter is larger, but it's been their experience that dielectric cables such as ADSS tend to pick up less ice, likely due to less thermal conductivity.
Yeah, I understand that's what ADSS kind of promotes. What we're looking at is kind of a worst case scenario typically. Um, like I said, we're not when it comes to spacer cable, we really focus on the messenger, and we take the added weight of the phase conductors and the spacers themselves, and we have an idea of how much surface area they'll tend to pick up. We'll use anything from SAG 10. Most of our engineers these days are using PLS CAD, and we can model that ice buildup. Um, we've got a lot of pictures. I think some of them are here in my presentation that shows us during ice storms and bringing trees down on the spacer cable system, and it tends to perform really, really well there. Um, we that's what we typically see. I can't really speak to ADSS. I know that's one of the things that they promote, that it'll pick up less ice, but I'm not sure what the principles of that, or what the cause would be. I just know how we model it with our cover conductor. Tree wire is obviously kind of the same thing. You're dealing with a lot more surface area. Um, one of the issues with tree wire is the supporting structure and equipment for tree wire is basically the same as it would be for bare wire. Your dead end shoes that are attaching directly to the ACSR are going to be the same, but you're just adding a covering kind of mid span to that. So you've got a bigger surface area, you've got more weight. It's almost like you're derating it. Um, as it's installed, and then you add more ice and wind loading on top of that. So that's one of the reasons that you have to, be cognizant of your span lengths when it comes to tree wire, and you don't really have that strong support of that messenger, kind of keeping it up in the air. So it is a bigger concern with tree wire than it is spacer cable. Um, Speaking of ice storms, that was a good segue into our storm hardening. Obviously, that's one of the primary applications for spacer cable. Clients looking to improve their reliability indices. Some will come to us, and it may be one of the questions that we have here is, where do we start? I always tell customers, you know, you're looking at, well, we want to improve our reliability. Okay, you want to reduce your outages. Let's take a step back and kind of figure out what's causing your outages. Uh, where can we help? So a lot of times they'll start with like their worst performing circuits, right? Um, and you can walk into any of your line crew rooms and say, here's our worst performing circuits. Take me to the trouble spots. And a lot of times it's going to be in heavily treed areas. that either, don't get trimmed very often, or it's just a species that grows really fast, or they've got landowners or homeowners that are, running them out of there anytime they come in and try to trim the trees. So, those are typically, good places to start. We understand, spacer cable is not something you're just going to start, building everywhere and building everything out of spacer cable. You kind of got to pick your spots and find out where you can get the most benefit out of it. But like I said, we size everything by the NESC loading zones for your area. And we really focus on, again, sizing the messenger and the span lengths for that. Like I did say, you're going to have to increase the size of the poles, pole classes, most likely, but you can typically get by with shorter poles. So it's kind of a nice trade-off there. Um, Typically, if you can get a thicker pole, a lot cheaper than you can get a taller pole. One of the biggest mistakes that we see clients make is, their standard class 5, class 6 poles that they use for bare wire, and we're going to convert this line to spacer cable, and they use those same size poles. What you've done in those cases is you've moved the weak point of your system from the wire to the pole. And that's what we try to avoid. So again, that's where some of those design services and consulting that we can do, we can really help you with the pole loading and give you some idea of the sizes of poles and the ones that need replaced. Our field service guys, we also use them for that. If we don't have a lot of intel on the existing circuit. Sometimes we'll send them out to kind of do a pre-designed walk down where they can walk along, and that's one of the big things that they'll look at is the condition and the sizing of the poles. The other thing is guy leads. With a spacer cable system, you're not going to be able to get away with those 12 or 15-foot guy leads that maybe you use on your ACSR. We try to get as close to a 1-to-1 ratio as we can with our guys. So, you may be looking at 30, 35-foot guy leads at a minimum. We want to build the system as strong as possible. Narrow right of way, if you look at NESC Rule 234-1, and that talks about horizontal clearance between overhead primary facilities and man-made structures, buildings, grain bins, billboards, and things like that. And there's a footnote there that says where available space, the clearance may be reduced by 2 feet provided the cables have a covering that provides sufficient dielectric strength. And that's what they're talking about is covered overhead conductor, in essence, spacer cable. So you can reduce that by 2 feet. It takes you from, I think, a standard, like a 15 kV system goes from 7.5 feet down to 5.5 feet. But then when you take all 3 phases and you've only got a foot from the outer phase to the other outer phase, you're really looking at a pretty tight window that you can get your 3 phases through. And if you have multiple circuits, you can stack them vertically, and that doesn't affect that horizontal clearance. So you can get them in a pretty tight space. Now, whether that's down an alleyway, in a an urban area, or between trees and stuff, if you want to maintain that. But this is a good indication or example where you've got these H frames. If they have to upgrade that size of conductor and they need to bring it up to the code, right? So converting it to underground, then you're talking ductwork and manholes and vaults, and then converting all of these services to underground. That can get pretty expensive pretty quick, or rerouting those facilities outside of that alleyway, and that can get pretty expensive as well. One option is to convert it to spacer cable. You can maintain the same location, and it's a lower cost option than what else is out there. Outside of tight right-of-way, heavily treed areas, probably the most popular application that we have for spacer cable is substation exits. And again, it goes back to, it's got very little to do with trees, obviously, but just getting more in a much smaller space on the pole. We've dealt with a lot of utilities where, real estate for substations is getting harder and harder to find. Maybe you find some that's a couple hundred yards back off the road and you've got a narrow right of way going back through there. So running all of those exits, circuit exits underground can get pretty expensive. Um, so spacer cable might be a good thing to take a look at. This is kind of gives you an idea of what we can do. This is 8 circuits coming out of a substation. I think this is in southern Indiana, but um, most of the utilities I work for would only put one. Some will put 2 risers on a pole. So if you've got 8 circuits, you're looking at 4 riser poles, right, at a minimum. A lot of times, a lot of utilities will do 8. So you don't see, exits coming outside the fence overhead, but as you can see on the right, it's still covered conductor, goes through those grips and then connects right up to the buswork, and it's all covered right up until those 2 hole paths that are connected to the bus. So still pretty resilient for wildlife getting in there, but it's just 2 pole lines, a couple of 90-degree angles, and it goes out to the road. There's another picture of some of the corner structures that we do. This is what I call kind of our typical cooperative, substation. You've got your 138 line coming in kind of down the railroad right away, goes into the substations. Then they've got 2 distribution circuits that come back out of it. One of the things you'll notice kind of in that lower right-hand corner is we don't need to install those intermittent distribution only poles. Again, with the size of the messenger, we can span it really as far as we want. So it's a pretty good application for transmission lines. Maybe those poles are 300, 350 feet apart, and then we just size up the messenger to do that. So it works really well, and it minimizes the number of poles. I've met in the past with G&T contractors that'll say, if there's any opportunity for there to be distribution underbill, we purposely have to put our poles a lot closer together. And with spacer cable, we don't have to do that. Wildfire mitigation is obviously a pretty hot topic, no pun intended, right now. Um, I'm not sure up in Canada if that was one of the concerns when they put this in, but it's a good picture to kind of show what they deal with. This is an older circuit that's been up for quite some time. The reason they use spacer cable here is they can only get to this spot in Banff National Park a few months out of the year. The rest of the time it's hard to get to, and there's enough snow in there. So they do come out here, twice a year and do a walk down inspection. And a lot of times their vegetation management group has to cut some of these trees off. And if you look down through there, you see 3 pretty good sized trees just laying on the messenger. That keeps it up off the ground, keeps the lights on. And that was really the goal there. But any hard to reach areas, difficult installations, mountainsides, these are some relatively new pictures from some utilities out west. They're really targeted spacer cable for wildfire mitigation. You could see a double circuit on the right, pretty clean installation. Not a ton of overhead trees, but if you look at the one on the left, those are pretty hard to get to areas. So if those trees come down, we want to make sure the conductor stays up in the air. A lot of people are kind of focused on, cover conductor for wildfire mitigation. They don't want it to spark when it hits the ground. Our goal when it comes to spacer cable systems is really keep it up in the air longer. You want to minimize, damage to the line, damage to the poles or the brackets or anything like that. And if we keep it up in the air longer, there's little to no opportunity to ignite. The one on the left here shows one of our longer spans. Like I said, one of the key benefits for spacer cable is, um, to do a longer span, we're focused in again on the messenger. We don't have to increase the size of the phase conductors for those span lengths. Whereas if you do bare wire or even tree wire, that cable has to support the tension for that span. So, you may have, you may only need, some watt out or some 336, but if you've got a long span, you may need to increase that, three or four sizes just to withstand the tension that that span is going to create. When it comes to spacer cable, it's all 30-foot spans that are on the phase conductors. So I can really span it as far as I want. I just increase the size of the messenger, which is a lot more of a cost-effective solution than having to increase all the phases. So we do a lot of, 700 foot highway crossings, um, waterways, rivers, um, the ravines. The longest one we've done, we've got a 1,600-foot span over a lake in northwest Indiana. And this was, believe it or not, the cost of this project was about 25% of the subsea cable that they were originally looking at. Now those are pretty heavy duty poles. You can tell there's quite a bit of sag there, um, but it was a lot. It was about $250,000 compared to, the original estimates were going to be closer to $1 million to run the cable underneath the water. So it worked out really, really well. And that's been in service, I think, for going on 20 years now. It's been up there for a while. I always throw this picture in here because this just kind of gives you some idea of the dimensions at a 15 kV system, then from our 25 all the way up to 46 kV, how much you can get. It gives you a little bit of scale here. So it's not beyond, it's not tough to think that you could get, four circuits of 35 kV on a 45-foot pole. It's going to be a beefy pole, obviously, but the space is going to be pretty efficient. Those are the primary applications. I wanted to pause here to see if there's any other questions on applications that we could answer real quick. Nope.
I'll
Okay.
hold the questions till the end, Ted.
Okay. So when we talk about, when I mention, storm related, storm hardening, things like that, um, we're always continuing to look at a spacer cable system and how can we improve it? How can we make it perform better? The basic concept of it hasn't really changed all that much. We've made some improvements to the design of our spacers themselves. Um, some people may remember the old ring tie spacers that had the little rubber bands that hold the phases in the saddles. Our insulator products have come a long way. That's just here in the last 10, 12 years, we've added quite a bit to that offering as well. And one of the things that customers were concerned about was, if the wire does come down, whether it's damage to the bracket or the pole or something, we'd really like to know that. And we've recently partnered with this company called Automation to develop this impact alert. I won't go through this rather busy slide, but we do have a webinar that'll go into this detail here coming up closer to the end of March. And you'll be able to sign up for that if you want to learn a little bit more of that. But kind of the Cliff Notes version of this is you mount it to the messenger. It's going to detect any kind of impact, any kind of movement of that spacer cable system. It'll tell you if there's been any damage, if it moves around and that angle changes and stays the same, or if it goes back to normal. One of the biggest things that we can see, clients using this for is kind of building up a business case. It's like, you see the impacts, you see the potential outages that on a bare wire system, would have resulted in a sustained outage or a truck roll or whatever. Whereas with your spacer cable system, you saw nothing. But more than anything, we want to make sure that if there is some kind of an incident that somebody goes out, relatively soon afterwards and takes a look at it. We don't want trees sitting on a spacer cable system or a tree wire system for that matter for very long because it's not fully insulated. So it'll eventually, work its way through that covering. Now, it could be a month, it could be 6 months, it could be a year, but we don't want to cause any damage to the covering. So we want to clear those trees off there as soon as possible. Um, One of the other questions I'll get a lot of times, especially when I show those inaccessible areas, is how do you get those spacers out there? How do you install that? And this is one of our newer installation methods that we've got. Actually involves two different messengers, um, and you'll string one messenger across and you'll tension it, and then you'll use that first messenger to literally pull a completed spacer cable system across a hard to access area, whether it's a roadway or a highway, a river crossing, or just, we just did one here a few months ago that was over a building. It was all up to code. It just couldn't be avoided. So, but it would be really, really hard to access. So, um, this is just an indication we're constantly looking at more efficient ways to install spacer cable. As most of you probably know, the biggest component to, cost component to any project is the labor to install it. So, those are this method, having our field service folks on site to make it a more efficient installation process. If we can minimize that installation time, it'll really help offset the added cost of a spacer cable system. And in some cases, if you can put this up, in some cases faster than you can bare wire. I know this method versus our old roll by method cut the time by, like, I've heard anywhere from 60 to 75% faster. So, and then when you get done, it's a completed. So on our website, we've got a quick video that kind of shows a demonstration of this. And we've got a couple other, things out there that'll might be of interest. The other thing, we've always wanted to, as I mentioned, we want to protect the poles as much as possible. And a lot of customers will report, broken poles. So with a spacer cable system. So one of the first things as an engineer, we kind of take a step back and we look at the size of the poles and the span lengths and all that stuff and how loaded up they are. And that usually, is one of the culprits. There's, you just can't design a spacer cable system or any overhead system for that matter that can withstand any amount of force. So one of the more recent innovations that we've come up with is kind of a breakaway, like a shear pin bracket. So this is designed to absorb that initial impact of a good sized tree or tree limb on the spacer cable line. And really what it's designed to do is protect the poles. So we're seeing more and more heavy poles, ductile iron, steel poles, even some concrete poles in some cases, fiberglass composite poles that'll give you a little more flexibility. And when you think about, a system being super rigid, that tends to, lean towards more breakage, more damage. Whereas if we get a little flexibility in that, like with a shear pin bracket pole or a flexible pole, it makes it a stronger system. So this is one of the things that's available. And if you want more information on that, you could check that out on our website. Speaking of our website, our marketing folks would get after me if I didn't mention this. Smartmanutility.com, and you can go to sections on our power cable, our molded products, and our ACS products. Uh, Specifically, if you find our resources page, if you work in spacer cable, especially, but any of our other product lines, bookmark that resources page. You'll find cut sheets, you'll find technical papers. We've started to produce a lot more videos, and this is our YouTube page where we've done some of our demo videos and some of our marketing stuff. But like I said, we've got um, some installation demo videos on that double messenger and some other things. Our webinars and stuff are all out there. So we're really building up a really good library. But spec sheets, all those drawings that we talked about, all of our catalog cut sheets, all of that stuff is on there. So definitely bookmark that. So we do have a couple more webinars coming up. We're doing a Key-Write one here in a couple weeks, March 5th. Our Key-Write benefits and applications. And then we're going to dig kind of a deep dive into that impact alert and a little smart grid, intelligent circuit monitoring type of a discussion. That's coming up later in March. The bigger trade shows that we're going to, the national ones, Tech Advantage, coming up here in March. We're going to be at Bulk Booth 301, and then obviously IEEE in May, which I believe is in Chicago this year. Um, Kristen can confirm that. It's right in her backyard. But we'll be at booth 24, 26 for that. Um, One of the key things is if you're sitting in today and you need continuing education credits for your PE license, or if you're an EIT and you're trying to build up some of those hours, get in touch with Kristen. We can send your certificate and at least give you an hour of instruction for sitting in today. Um, so that's her email address. I think we're, yeah, right at 3 o'clock Eastern. So we'll have a little bit of time here for questions. Um, do we get any questions, Kristen?
Yes, we had a couple. One we had already answered, but I will go ahead and ask this just for everyone to hear. So there was a question regarding the difference in tree wire XLPE versus an HDPE jacket and whether one was tougher than the other. And our engineering response was that the thermoplastic HDPE is very tough and similar to the HD XLPE tree wire jacket. So I just wanted to answer that one since that was in the Q&A. So here's one
Yeah,
for you, Ted. Oh,
the
unless you
big
have.
the biggest difference between those two materials is going to be kind of the, you know, it's not a, you know, it's kind of unusual when you look at overhead wire to actually have an operating temperature. With bare wire, you know, most people don't worry about that. Whereas you'll see our standard conductor is HDPE and it's rated at a conductor temperature of 75 degrees C. We also have kind of a, we call it our 90C cable that you can run it a little bit hotter. And the reason we have that temperature rating is we don't want to cause any damage to that covering. So those numbers will be good. And that's what we use for our ampacity ratings and stuff like that. So like I said before, we make it in black and gray, and that also affects the ampacity as well. When you look at HDPE, which is our standard product, we've had it in the market for, you know, that's always been our base product, and we've made that since the 50s. XLPE will tend to be a little bit more rigid, but more than anything, um, it has a higher emergency rating. So we'll run it, we rate it at the same 90C cable that our 90C HDPE is, but you can get another, I think it's 20 degrees of emergency overload before it causes any kind of damage to that covering. So you know, most utilities try to avoid that emergency overload. You know, that's going to be, you know, 48 hours or less. But it's rigidity, you know, reliability wise, rigidity wise, it's going to be pretty comparable to HDPE. The cost is a little bit more on XLPE, but you know, we'll let the sales and marketing folks talk about that. But the big thing is that emergency overload.
Thank you, Ted. Next question is, if a utility wants to extend an existing installation of Hendrix from where it transitions to bare wire, would they simply splice the two runs of Hendrix together, or is the system designed to be continuous with no splices along the way?
Well, like any overhead system, we try to minimize the number of splices. You know, but obviously, you know, that could get, you know, pretty expensive, especially if you've got, you know, a bunch of existing spacer cable, and then you want to extend it. You know, it'd be, you know, the sales folks might kill me for saying this, but it doesn't make a lot of sense to have you replace all that. Now, that being said, if that spacer cable's been up there for 30 or 40 years and maybe you're on the edge of you know, replacing it anyway, either from a load perspective, you know, it might be a good idea to replace it, and then you can have one continuous run. Um, but it's not, you know, it's not required. If it's in good shape, and I get a lot of questions about, you know, how can we test it? You can't high pot it, you know, you can't impulse test it like you can with underground. Thermal imaging is really only going to tell, you know, you may find a crack in an insulator or something like that, but we don't tend to see a lot of heating from a degradation in the covering because it's all the same voltage, right? We just don't have that leakage current. So the best thing to do is a visual inspection. Now, one of the kind of the plug that I'll have for our field service guys is we'll come out and look at it for you. We're actually going to start doing drone inspections, high definition inspections of existing lines. And that'll help us out, to get up in there really close and get a good look at the covering without having to get a bucket and go up and doing all that. If it's in good shape from a visual perspective and you don't see any discoloring and it's 336 cable and that's what you want to extend and it's going to work out for you. You can just dead end it on the back side of that pole, just like you would a transition pole, and then connect the two covered conductors together and then just extend it down. We would probably recommend you put a set of lightning arresters there. You may want to put a set of switches there too if it's a good spot for that. But definitely lightning arresters would be good, but it's not mandatory that you replace it. We'd love to have you replace it, but that's not required.
Thank you, Ted. The next question is in relation to that tree wire. They're asking, when you're pulling in tree wire, does either material, the HDPE or the XLPE, is either more resistant to tearing during installation than another?
Not that I'm aware of. We've had this discussion here a little bit lately. One of the things that's key when you're installing tree wire, because you are putting quite a bit of tension on it, may not necessarily as you pull it in. Now, if you're pulling it in up a good incline, that can be an issue. But more than anything, there are parallel groove grips that are designed specifically to go over covered conductor. Klein, I think, makes one, and we can follow up later and get you even a part number or a photo of it. But the contact area for that grip is going to be wider than what your standard parallel groove connector that maybe you're pulling bare wire or you're tensioning guy wire with. That's a pretty small area because you're not really worried about damaging the ACSR. But when you got covered conductor, to your point, you want as wide of a contact area as you can so it spreads out those force. I've even seen guys that will take like a preform grip that's sized for that cable and kind of loop it around there a few times and you get maybe a foot or two of contact and then you can tension it with that. It shouldn't be a ton, you may have to shorten up the sections that you're tensioning at once if you're starting to see tearing. Personally, for Hendrix, we haven't seen a ton of that, and we've got some pretty good sized cable that's been pulled in, but even tree wire. But make sure you're using the right grips that are designed for that to go over top of that covering. The design's a little bit different.
Thank you, Ted. That was all the questions that I have here in the Q&A. If any of the attendees think of something else, feel free to email me at kvanderwall@marmonutility.com, and I will pass that along to Ted and our engineering team. So that does conclude today's webinar. Thank you again for taking the time to join us. Just a quick reminder to please complete our brief survey that will pop up in your browser. We hope you have a good rest of your day and see you on future webinars.